thank you so much. So welcome to this talk about domain-driven security, and we'll see what that is all about. Since we're running a little bit out of time, we're not going to talk much about this slide here. Well, my name is Dan Deogum. This is my colleague Dan Berg-Johnson. We're both from Omega Point. Please Google us and you will find out
all about
a lot of stuff, I guess.
And now it's my turn. No, it's my turn to turn the page.
Oh man, clicker war.
Hey.
There we go.
Yep.
Right, so in case you fall asleep, these are the key.
My list is working.
Oh, that's good. Come on. So the key takeaways today would be that domain-driven security is actually a way for you to design secure software without actively thinking about security. It also helps you to attack or treat injection problem as a modeling problem and not as a validation problem. We're also going to talk about context mapping, and that is essential to avoid cross-site scriptings and other second-order injection attacks. And of course, we're going to talk a little bit about microservices and how scary that is unless you do proper context mapping. And you'll see what that is.
And if this looks like buzzword bingo to you, well, it is. At the end, we will have the same key takeaways, and hopefully you'll be able to check the boxes and say, yeah, now I get what they're talking about.
Right. So, during this talk, we'll go through 4 different quadrants. And the first 2 are the ones that actually gives you an introductory to the domain-driven security field, whereas the latter 2 are the ones, are you okay? Yeah, good. And the latter 2 are actually the ones where you get deep insight what's going on today and are more advanced, so to say. So the first one, simple domain attacks. Let's see what that is all about.
Okay, let's get to an example, a real-life example. A few colleagues of ours were doing a security testing of in-production web shop. Retailers selling something, large Swedish international retailer. They were not selling books, so let's say they were selling books, just for the sake of the example. And they were using different stuff to try to get into the system without any special success. And one of them got curious about the quantity field. So, just for the heck of it, -1 encyclopedia of everything. And to his surprise, nothing really happened. This order went through the process flow, ended up on the paying with the credit card, filling a shipping address, and okay, weird. Made a small note. Fast forward, 1 day later, a lady comes up from the economy department asking, sorry, that's a stupid question, but is there anyone here named Joe Tester? Okay, how come? You see, the economy system has just issued a credit invoice for a Joe Tester. And the strange thing is that the shipping address is this address, the headquarter address. And someone said that Joe Tester might be one of you. Okay, so the system had actually reacted in a sound way. It had issued a credit invoice on the amount of -1 encyclopedia of everything. Could this have been used some other way? Well, of course we did just get a credit invoice because we ended up in a negative amount. But let's say we had built up a pile of books we want to buy and then added -1. We just found ourselves a rebate coupon. Might there be vulnerabilities of this kind out there? Are they detected? Well, perhaps. Not necessarily so. So this is what we mean with a domain vulnerability of a simple kind. It's only one system. So if we look at this from a technical standpoint and look at the UVASC guide, they talk about in-data validation problem. And this essence of the advice and style guide is avoid in-data validation vulnerabilities by validating your in-data.
That makes perfect sense, right?
I can do that. Could you please elaborate? The problem is that, and they give some code example of the kind, if value is less than 0, don't accept. And the problem is that it kind of encouraging separation of the validation as a technical concern that's pushed to the corner, to the edge of the system, and the data and the model, which is kind of residing in the middle. So often this ends up with a lot of regexps, regex matching in the some presentation clear. Afterwards, some realized that we should better gather these, so they are wrapped up into static methods in some kind of util class. Anyone seen that? Util common. Book sales dot util, and it's 200 methods. When they end up there, you realize that, okay, we've got lots of coded application, not necessarily textual, but the same idea repeated a lot of times. There's kind of not necessarily consistent with each other. Plus, we've added a huge dependency network, because this util will have dependency to and through everything. And when you go in microservice architectures, you'll see it's a problem right now. Doesn't work all well. So, if you now apply domain-driven design and try to reason about it, we can make one observation. Is that quantity is actually de facto modeled as an integer. Well, that's the way it's been modeled. However, quantity is never spelled out in the code. It's there as an implicit concept, meaning we cannot put restrictions on it as a kind of first-class citizens of what we talk about. So the analysis is that the modeling is incomplete, or perhaps just missing. Someone said, yeah, and then you can order 4 books. And the developer thought, oh, that's an it. Okay, so what we want to do about it? If we're trying to solve this in a domain-driven design mindset, we say that, okay, this is not about in-data validation, it's about modeling. There's an implicit concept that needs to be made explicit. So we want some kind of explicit quantity, so that when talking about order lines, we don't want to talk about strings and ints. We want to talk about ISBNs and quantities. Outside of our domain, it's a -1 when the tester actually entered the field, the -1 value into the field. But here we want to regard it as a quantity. And now we can say that -1 is not a sound quantity. To be very specific, we make it into a class. A good old-fashioned domain-driven design value object class. It's immutable. There's a lot of finals over here. And it's got a contract. And we see that it's not only we are forbidding negative values, we are explicitly allowing strictly positive. So somewhere has been a domain discussion with a domain expert asking whether 0 is a reasonable quantity. And this is a good starting point for a domain discussion. So, what's lower bound? Next question should probably be, what's the reasonable upper bound? Is it reasonable to buy 10 books? 100 books? What about if someone orders 1,000,000 books? And somewhere here you will gain deeper understanding when the business experts start talking about the logistics flow and no, we cannot ship more than a crate of books or something like that. We had a very specific problem with that. We were running our student conference and we wanted 120 books of 97 things every programmer should know. And we tried to order them through one of their 2 famous websites. So we actually used both of them, and both of them they failed to be able to deliver that amount. They were designed for delivering a few, we guess.
Oh, not that they rejected it. They said they were going to order it and deliver it for us.
They just didn't show
They
it.
just not ship it.
So it would have been nice to say, I have got a message that we're sorry, 120 books is not in the normal flow. Please contact our sales representatives or something like that, and they will get you in contact with the publisher, because that's where we ended up at the end of it. So if we do this, we will end up with transferring all our service methods from this kind of by book, which is an explicit domain modeling, and with language primitives, and instead using some kind of domain primitives. We're building a library of domain primitives, which can raises the floor of the discussion, makes the code more expressive, and thus consolidate a lot of business rules, hiding them away and making lives easier for the rest of the code. This is actually what we recommend. Look for your service level methods and try to have all parameters and return values being some kind of domain primitives that you either crafted yourself or comes from some kind of standard library as the ISBN.
Right. So now you've been to this talk and you go back to your code and you say, well, you know, that quantity, that was so trivial. In my world, where everything is complex, I have something, let's say an email address, and then you try to apply the same kind of rules that you did with the quantity. And you go like, yeah, it should be a contract that sort of validates or creates a whitelist of acceptable input. And you go, wait a minute, how do I define an email address? Well, because you're engineers, of course you move on to the email specification. That's what we do. Then we find out that there's an RFC 5322 and section 3.4 that explains this. And as you can see, there's some okay examples.
Great detail.
Yes. There's some okay examples there that you can see. And then you start realizing, wait a minute, somebody has probably written a regular expression. So you Google that, and you find it. There have been attempts. And some of them are quite successful. They're not 100% perfect. And as you can see, this regexp that I'm showing here, it continues for another 6,424 characters. So that makes you
pretty good, because it captures most of the specification. It doesn't cover some interesting corner cases, but actually most of the specification.
So the first approach, of course, you copy that and you place that inside of your class or your constructor there, and it looks terrible. And you go like, oh no, this is not probably what Dan and Daniel meant. Exactly. One thing that Eric Evans, who is the grandfather of domain-driven design, was talking about is basically that you need to specify what makes sense in your bounded context, in your domain. And that's exactly what you need to do with your email address. So when you talk to your business experts, you need to say, well, let's go back to this slide and say, hey, should we accept this kind of strange email address as a £, $%, and so on? Is that a valid address in our domain? Should we accept these kind of addresses? Yes, it's correct according to the specification, but in our world, our little tiny world, is this okay? Should we accept it? And then you get that discussion going. And that's what it's all about. You need to specify your domain and let it grow, so your model grows. So, we basically talked a lot about domain-driven design. So what is this domain-driven security? Well, as it turns out, back in 2009, Dan here and a former colleague of us, John Wilander, they came up with the idea that you basically use domain-driven design and tools from it and mindsets from it to address security issues. And that actually helps you to implicitly attack certain security problems without you even knowing. And that's the beauty of it. And something that I came up with, well, the other week actually, is that in case you are at a client or at your current project or wherever you are, and you say, hey, I want to do domain-driven design because I find that it's extremely good and awesome, and that's really what I want to do. And people start arguing against and say, no, it's just too expensive, takes too much time, and whatever reason they come up with.
Has that happened to anyone? We would try to do domain-driven design or something like that, and people go, wow, that will take too much time. We better start coding.
So, but then you ask them another question. We have problems, with security, injection flaws, cross-site scripting, blah, blah, blah. Should we address those? And they go, yes, security is the most important thing. That's the top priority of our, company. But then you go, sure, let's fix them. Let's use domain-driven design, or DDSec. Fantastic.
So, a very brief history of domain-driven security. The term was coined back in 2009 in a discussion between me and John Delander, and it was initially presented at the UVASP Europe conference in 2010. It then showed that in Oslo, Erlend Oftedal had taken a similar line of thought, not naming things using the same terminology, but essentially doing the same thing. So we consider him as one of the coiners of domain-driven security. We presented this at various conferences, and the year since then has mainly been used to gain more insight by industry practice. And this is where Daniel Jorgen and our esteemed colleague Daniel Serrano also come in, and deepen that understanding, presented this summit, and now we're at just this fall before Christmas, presented at DevOps, at DD Europe, and now at JFocus. So we're getting up to speed again. We've got a lot of industry practice, and we want to promote this as a tool for you to as developers to get better security without having to think security all the time, but rather concentrating on design habits, coding practices that you think is a good idea anyway.
And it's always funny that Dan, he seemed to skip this little last part at the very end there.
Which one? That's nothing at the end.
Yeah, that's a very early work on a book about this. So
it will be there.
Stay tuned.
Mm-hmm. Don't hold your breath.
Yeah.
Keep your eyes open. Okay. So we have now covered the simple domain. Now we're domain attacks. We're moving over to the technical attacks, still staying on the simple side, where we are attacking one single system.
Right, and what comes up in mind then is, of course, injection flaws. And in case we don't have time to read all this, the key takeaway here is that we somehow get untrusted data that trick your interpreter into doing something that's unintended, where you can be able to access information or something, right? And of course, you all know SQL, and here Dan is logging in. Apparently his password is cats are cute.
Of course they are.
And he gets access, but then there's a evil hacksaw that does the same thing. However, evil hacksaw's password turns out to be apostrophe or 1 = 1 --, and by magic, evil hacksaw gets access.
Because the query matches all rows in the database.
And of course, we can demo this. Another colleague of ours, Daniel Hultqvist, is he in the room? No, guess not. He skipped this part. That's good. He wrote an application that's vulnerable. It's some sort of fusion between Facebook, Instagram, and 9gag. I mean, this guy's young. He knows all that stuff. And yeah. So he basically wrote one where we can actually demo these kind of things. So let's go there. Can you see this? Yes, you can. And I have a screen up there that I can see.
The code is available on GitHub, Omega Point account/Facebook. Please download and play with it.
So, or 1 = 1 --, is our
username.
So let's pick a password. That's good. And let's see if we can try to log in. Oops, it's kind of hard to click that. Ooh, you also don't get access. So what happened behind the scenes? Well, let me see if I can press play again. There we go. So behind the scenes, apparently or1 equals 1 is not a valid username. And that is something that, of course, somebody would claim in your organization. Like, no, you can't log in with or1 equals 1. But that's my favorite username. Why can't I use that?
Hey, username's a string. You just said it.
Yeah. So, and this concept is unfortunately implicit in our code. And that somehow needs to be made explicit. And this is where that modeling comes into hand, right? You need to start working on those. But then somebody, of course, comes up with, you know what, Dan and Daniel, prepared statements solves SQL injection. And I go,
And they do.
they do?
They do.
Yes.
And they're actually the preferred way to solve SQL injection.
And why is that? Well, that's because, of course, inside of your context, you're working with that username. And when you start commuting with the persistent context, you need to translate something into that context. And that's what you do with a prepared statement or a parameterized query.
But what if you are compiling strings where you do not have prepared statements?
Right. So that's a problem. And of course, there's also other injection flaws compared to SQL injection, like LDAP, command, XPath, HTTP header. Wait a minute, HTTP header? Please explain that one.
It's an interesting case. Any way where you compile a string, you're vulnerable to injection flaws. And when you're crafting a HTTP response, you're compiling a string. So, a concrete example. Let's say that we've got a site where you can browse articles, and you've got a cookie with your favorite author, and this author I'm very fond of, James Smith, is stored in the database or some user setting or something like that. The HTTP response that's crafted will contain a set cookie, author James Smith, and then comes the real content. So HTTP 11/200, okay, you know what the HTTP response looks like. So, Evil Hacker managed to somehow change my user settings into having the favorite author Wiley Hacker /r/n HTTP 11/200, okay, etc. This gets rendered into my HTTP response. Set cookie author, Wiley Hacker, blam, HTTP1, and injects a full HTTP response in and of itself into my string, pushing the real content in front of it. So when this gets back on the TCP/IP connection, the browser will react by, well, here's a 200, I tried to render this, and it seems to be incomplete. And it will react some way, either it will just do something, and the user will click reload, and then the next request on the stream will be loaded. Or it will just skip the incomplete and load the next one. Anyway, what shows up in the browser is the hacked content. So we've injected maliciously crafted data into the stream of the HTTP response. Solve this with a prepared statement.
Yeah, we got him. No.
So, domain runs the security to the rescue. So the analysis of this, what we should have done is, of course, that we should have modeled author as the cookie value, so it cannot violate the HTTP specification. Not allowing this control light theme that makes it able to spill over to the message body part of it. Okay, to be fair, we should put a little bit part of the blame on someone else. That is the design of the Java serverless cookie API. They should have designed their API so that it's not vulnerable for us to be able to put in a string that cracks this model. So, yeah, this is basically the analysis of what it looks like. Looking back on injection flow, so DDD help us enforce this separation of data and code. And doing that by focusing that we validate with respect to a model. We cannot just validate. We must validate with respect to a model which we can craft ourselves after our needs. And that is kind of the crucial point here. A quick note on validation. There's a lot of things that need to be validated. And a good order to validate stuff, proposed by Dr. John Wilander, is to validate that data comes from the correct sender, a legitimate sender. If it does not, do not touch it. Then check the length. If someone has sent you an XML string that is 10 gigabytes, well, you're probably under a DOS attack. Reject it. And do this before you start going into parsing it. Next step might be to check on the content of the text, like seam level. Do you want to allow XML entities, for example? If you there's a neatly crafted hack which is named a billion lols, or a billion lols, which is a very small string but will expand to a billion lols.
Promise you Google that.
So Google that, billion lols. You can avoid that by not allowing XML entities.
Yeah, I guess you could also Google XML external entity attacks or XSE attacks. That's the same thing.
So then, and only then, you can check the content structure, actually do XML parsing, and then check the semantics. That is this a sensible thing to do at this point in time?
Right. So now we've been warmed up. We've gone through the first two quadrants, where we basically looked at simple domain attacks and simple technical attacks. So now we're prepared to move it into something that is a little more elaborate and a little more sophisticated, and that's of course the complex technical. And complex technical attacks is that we use systems of systems in order to do our attacks and see how we can protect against that. So what first comes up in mind is of course cross-site scripting. OWASP does not actually label this or categorize this as a second order attack or a complex attack, but we do. And the reason for that is that the cross-site scripting is really that you somehow get untrusted data to execute in the browser, or you actually make sure that your primary attack isn't the first system, it's the actual browser of somebody else. And what that means we will actually see in a very
So the target of the attack is kind of like behind what looks like the target.
Yeah. So let's go back to our facepalm application, which is so fun. And now let's go in, we logged in, so let's make an image comment. Try and see here, say hello, and imagine this would be a coder's blog. And now that I'm a junior developer, I wonder, what does this script mean? So script, I can't even see what I'm typing. I hope I'm typing the right thing. Alert. I'm not?
Stop.
Oh, let's go back. It's so tiny. Can't even see. Okay, so hello script.
Yep.
There we go. And there's a alert. 42. Is that good?
Yeah, you're fine.
All right, and there's a
I'm
close.
doing the parsing.
Script.
Parse error.
Parse error.
Yeah.
Are you serious?
Back up. Script slash stop back parsing.
Script.
Slash script.
Slash script. Yes, you're right. My gosh, it's tiny.
Bracket.
Bracket slash script.
Back up 3 letters. That is it.
Is that good?
Yeah, brackets.
Bracket.
Now you're fine.
Okay. World. Smiley face. There we go.
I've never played the role of IntelliJ. This is great. You should do this more often.
I never played the role of a blind programmer either.
Parse error.
What happened? All suddenly, we got a pop-up box, or alert box here. And as you can see, it says hello down here, right? So it started going from left to right. And now I'm going to press OK. And we got the rest of our content.
And someone visiting the site will have the same
Experience.
experience in their browser. And of course, it's not an alert box. It's a port scanner. It's a keylogger.
something that
Something
actually
naughty.
downloads some malicious stuff to your computer.
Don't try this at home. It's illegal.
So, let's look at this from a domain perspective, right? So apparently we were entering this, or I was trying to enter text in some kind of context, right? I was asking a question about, something. And then that piece of data got transferred into some other context, a persistent context.
Our conceptual domain, where
Exactly.
we think this is not just text, it's a comment.
It's a comment.
We interpret it as a comment. We regard it as a comment.
And then later on, it was me or somebody else that gets a chance to reply to my question, fetches that data, and that data gets sent to this other context. And what
The reader's
magically
browser.
happened was it did not get interpreted as text in that context. It got interpreted as code. So it got executed. So this is really a problem when it comes to understanding that you are, in fact, traversing different boundaries of semantics. And this is actually really tricky to understand. That you are actually in one bounded context, let's say a writer's context, storage context, and then reader's context. And data gets passed across these boundaries, and now we need to do a mapping between those different contexts. And therefore, of course, in the reader's context, we need to do proper escaping of that data. Makes perfect sense. Unfortunately.
Or to sharpen up that sentence a little bit. When traversing from the domain context to the reader browser context, when traversing, we need to do a proper mapping. In this case,
yes,
by adding the proper escaping. So it's being aware of that you are changing contexts. That's the key of understanding what is the true nature of cross-site scripting.
So having a proper context map in your application between your various parts is essential, because otherwise there's a risk that you accidentally let data travel from one place to another and it's actually harmful.
Okay, so we looked at SQL injection and cross-site scripting. And if you have a look at them, they look like they have very different architecture, these two attacks. SQL injection traverses from the presentation layer down to the application, down to database, where it manifests as matching too many rows in the database, or doing something in the database. Cross-site scripting seems to have another topology. It traverses down from a presentation layer down into the application layer, touches the database, and goes up into a different presentation layer. By the way, there's a variant of the cross-site scripting that does not touch the database. It can get reflected on the application layer. So it's just passed down to the application, then sent out. Still, these two look very different, and they have been regarded as totally different attacks. Now, if we draw these to a little bit different, not using a stack, but using a lattice of hexagons, we get the attack coming from the presentation tier through the application and down in the database where the data manifests itself as code, causing the vulnerability. Or cross-site scripting. Data come from presentation tier, passes through, in the reflected case, through the application, not going to the database, and then goes over to the other context, the other subsystem, the reader's browser, where it manifests itself not as text, data, but as code. Do these two look really, really fundamental different now? Nah, they look kind of similar. They got the same topology. And this is what we mean when we talk about cross-site scripting being a complex attack because the issue is that it's traversing borders. And actually, SQL injection is also the same kind of attack. It traverses the border, and its problem is that it's misrepresenting the transition between application and code here in the database. So they're actually the same, if we look at it from this perspective. I'm really fond of this way of drawing architecture. It's called hexagonal architecture because you know the architecture as a lattice of hexagons. It doesn't focus on a stack of up and down, but rather on inside and outside. And I think it makes it lots easier to think about architecture. If we take the same notation, I think it also makes it easier to understand more convoluted attacks. For example, second order injection, where you make an injection, but not at the first system. For example, you enter a username a lot of times, which makes the application detect this as an intrusion detection and logs that username in the log file. At a later point of time, the system administrator uses the log admin tool to look into the log file and views that username, which is maliciously crafted to create an attack in the log admin browser.
As a concrete example would be, let's say you're injecting, let's say PHP code or some other crazy language. And it happens to be that the log admin tool is written in that language. Inside of our application, that line of code with that string is harmless. But as soon as it enters the log and gets read by that admin tool, it gets very, very vicious.
And of course, the log admin has probably got pretty decent privileges at that point of time. So, understanding this by drawing it as stacks is really hard to understand. Drawing it as a lattice of hexagons makes it a lot easier to understand. So, second order attack via the log is one. Second order attack, data leakage through logs of also common. Also kind of a second order attack. So, yeah, data leakage, interesting problem.
Right. Oops, there we go. So data leakage is actually accidentally we're leaking out data into parts or components or subsystems accidentally. But we somehow get either log it or we send it somewhere or we're not really aware of it, and then we use it. And one of our colleagues, or my co-speaker at my second talk here at JFocus tomorrow at 9, Beyond Lambdas, the Aftermath, Daniel Savano has created this tiny little pattern and basically handles sensitive values. It's not externalizable. You can only read it once, and as soon as you have read it, it gets destroyed. So if you accidentally log it or do something with it, and then where you're supposed to use it, well, you get a contract violation.
So this could be passwords, could be credit card numbers,
right.
It could be call center information, it could be any sensitive data that is not allowed to be leaked because we just accidentally logged it somewhere.
Exactly. So it's a pretty neat trick you can do in case you want it. Man, I just realized we have a really bad entropy when it comes to our names in our company. Daniel, yeah. Oh, never mind.
We should revise the
Yeah. So how did LulzSec help us out this time? Well, as it turns out, DDD gave us a deeper insight of the nature of cross-site scripting. And that was really good, because then we can actually prevent those from happening. We also used context mapping to detect broken maps and all those problems that comes with that. And then we were able to model confidential values or sensitive values. And by using that sensitive data pattern, we were able to prevent second order attacks. Pretty nice. Right, so the last quadrant, and that's good, we're on time, so that's good. The last thing we're going to talk about now is complex domain attacks, and this is where the latest findings will come in. And well, I guess Dan, take it away.
Yeah, you remember the initial example where we have bookstores selling -1 encyclopedia? We've said that the order system is probably integrating with the finance system, sending -1 times the amount to the finance system. It probably also interacts with the storage system, inventory, and the shipping system. So it sends -1 to the storage system, which decreases the inventory with -1. That is, it increases the stock level from 26 to 27. So the finance system and storage inventory system are actually consistent. It also sets -1 to the shipping system, where the data will be just regarded and disregarded because, hey, this is a broken shipping line. I can't ship -1 book. I can't put that from price. So it throws an exception. It ends up on the system log together with the other gazillion exceptions.
Who reads those anyway?
And no one ever looks at those. So, from an IT perspective, everything is consistent. And you simply get away with it. And this will probably be detected at the end of year inventory when they make an inventory of the storehouse, realizing there's one book too little on the shelves compared to the system. Coming to the conclusion that obviously the storage guys has nicked this one.
They're thieves. Yes.
Will this go undetected?
But Dan, come on. The real reason why this actually worked was that this is a bug.
Okay. So if we shall actually look at the true complex domain attack, then it should be a domain attack where all the systems are sound, but the system of system is broken. So let's jump to another example. Another real-life example. This is an insurance company who was selling insurances over the counter, cash payment. So it was not a Swedish, it resided in the US. And they had some kind of monolithic application which they started to break up. They split the payment into a purchasing system and had the policies in the insurance system. So whenever someone bought an insurance and paid for it, they issued a payment message which the insurance system listened for and prolonged the policy, setting a new end date, and also sending out a physical insurance letter to the customer. Fair enough. Here comes a new business initiative. We want our customers to be able not only to pay cash over counter, but also to pay by bank Jira payments. So we've got a banking system. We still make payment, and we keep payment because we do not want to break the downstream dependency. What happens if we break downstream dependency with other systems? They get pissed. So we keep it. It's just another form of payment. It's still payment. So Jira payment is a payment. And then we interact with the bank. So when they get a confirm or reject from bank, we map them to Jira confirm or Jira bounce. Everything works nice and fine and dandy until someone makes a Jira payment which bounces. Because the payment has been registered. The policy has been prolonged. The payment gets rejected from the bank, which ends up as a Jira bounce. And the people over here at the economy department, they will start talking to the customer and saying, you should pay your bill. But the insurance people over here, will not know it. The policy will be prolonged, they will send out a new letter, and if you crash your car, you will get your insurance money. This actually did happen. So now imagine that this is not 3 systems. It's 300 systems.
I always find this very, very amusing because when you start talking about microservices, going from a monolith to microservice architecture, one of the arguments is usually that we can make, surgical precision changes. You don't have to touch anything except that tiny little microservice. That's it.
So what should we have done? Well, we should have actually taken the pain to saying that when we add due payment, we need to rename payment to cash payment. We will break the technical downstream dependency. Well, in the previous case, we kept the downstream technical dependency, but we broke the semantic dependency. Now we actively break the technical dependency and thus unveil that we are breaking a conceptual dependency. This would make us open up a discussion about, okay, what should be mapped to payment? Well, cash payment, obviously, but due payment, no. We need the domain expert from all these 3 areas to realize that it's actually the due confirm that should be mapped to payment. So we need to obtain security, we need to take domain expertise from all the adjacent fields into discussion. Now, imagine that this is not an insurance company. It's instead a certificate authority issuing high-class certificates for internet. And they are not using 3 services. They're using 300 services, each developed and maintained by different teams or clusters of teams. Could there be a possibility for someone on the outside to try to traverse these by issuing an update and then rejecting and then pulling back and then editing and making this system of system confused until it actually issues a high-class certificate without having to go through all the proper authorization procedures? Yeah. So we think if we not watch out, we are entering a microservice hell here.
And you have to point out, though, we are not against microservice architecture. We're actually pro that. But you need to keep in mind that you do need to do your context mappings. It's extremely important.
We can't separate the concerns so much that we got this myopic view. And that is kind of a little bit what we hear in the claim of microservice architectures. You can make surgical changes. We say, yes, you can do that. But to keep security, you must be aware of this lattice of interlinked context maps and their mappings, the context and their mappings. Otherwise, you might get lost. So how do we guarantee that the context mapping is actually sound?
Right, so to wrap things up, for those who fell asleep, now it's time to wake up again. So, the key takeaways, by using those mindsets and nice design patterns from domain-driven design, you are able to attack certain security problems without even thinking about security. That's the nice part. You should also treat our injection flaws as modeling problems, not as validation problems. Context mapping is essential in order to avoid second-order injection attacks, or with microservices. And microservices will become very, very scary unless we do proper context mappings. So, for those who wonder where we are right now we're doing academic research on domain-driven security. There are 2 master's thesis projects going on together with the Royal Institute of Technology, KTH, here in Stockholm. We also have a cooperation with the Linnaeus University, their computer science department. Of course, industry practice every day. We need more data, of course, on the microservices part. And we're also investigating how domain-driven security can be applicable to DDoS attacks. And see if we can make that system behave more better. so to say. And also, we're in the early stages of writing a book that Dan tries to avoid. It's Dan, me, and our colleague Dan Savano, and as you can see, it's D. Yes. All right, so I think we have like 1 minute left for a question. 20 seconds.
Okay, and the small comment, the slides are out on SlideShare as of now. And there's a tweet retweeted by JFocus account that will give you the link.
Yes. Maybe one question. Is that okay? Yes, go ahead.
Yeah, so what comes to this complex domain attacks that we were talking about later, this insurance and the geopayment thing, isn't that something that gets kind of worse when you go from sort of strong consistency to...
So the comment was that if we are starting using eventual consistency, is there a risk that the kind of problems we are encountering in this context gets even worse? And I must say it's an excellent observation. When doing eventual consistency, you can do it either technically or you can try to model it. So actually embracing the eventual consistency in the domain, saying that we've got domain concepts for outstanding transactions, something like that, which makes this graph more complex. There will be more concepts around, and it's harder to make the proper mapping of them. I just must point out, I think the alternative is worse. If we're trying to do eventual consistency purely from a technical perspective, we will miss the entire point. There were some unfortunate Bitcoin brokers that actually went out of business because they had failed to model outstanding transactions as a domain concept, only regarding as a technical concept. So there's definitely a risk there.
All right, I think we're out of time. So thanks so much.